Thanks everyone for joining us tonight. Basically, I was going to share with you my personal obsession, one of my obsessions, I guess. So we're going to look at the 909 kick. So how many people know the 909? Or rather, I should have asked how many people don't know what the 909 is. So the 909 is basically a drum machine made by Roland. And there's a whole bunch of these machines made in the 80s, right? So the 909 was made in 1984. And what's interesting about the 909 is there's all these idiosyncrasies inside the 909. So when the 909 came out, you got to think there was like the Linn drum. There's these things where they're trying to basically make machines. If you're in a band and you don't have a drummer, we got the machine that sounds like your drummer. And so along comes Roland, and they're like, we're going to make it with synthesis and some samples, but we got to make it affordable. So that puts all sorts of constraints on this machine. And what the engineers did in order to solve these constraints, it's amazing. And that's really what interests me when I teach synthesis at CalArts and through Kadenze. And really what interests me is these constraints and how they apply to synthesizers. So one thing I've come across is that increasingly, like when I look at classic analog synthesizers, they share a common path. There's like an oscillator, there's an envelope, and there's a filter. And really what differentiates each of these is how they're routed, the modulation that you can do with each of these, and the constraints placed upon how you get your sounds. So this is what I find really interesting. So with the 909, there was all of these considerations about how do we get sounds that we want, sounds that we're excited about. And the thing that I find really cool is you got to think in 1984, they weren't building this machine like, oh, this kick drum is going to sound killer in Detroit. This is going to make like house music forever, right? When they were making this, they were like, oh, that sounds like a rock kick drum. That is just the thing. So a lot of the decisions they made were informed by what they were trying to go for, but this opened up this whole new world. And so in REAKTOR tonight, we're going to build this kick drum from scratch. We're going to understand how it works. And we're going to see how we can take what they built like 30 years ago and find out what we can do moving forward. How can we take these ideas and make new kick drums? And not just kick drums, but whole other percussion synthesizers. So let's hear a little bit of what this sounds like. So this is my personal patch I've been working on. It just consists of a bunch of different custom REAKTOR stuff. Lots of fun things like the 808, another rolling kick drum, is made by basically exciting a very resonant bandpass filter. So I have that in here at some point. And here's a 909. The same thing. We're going to dive in and look at all of this stuff. But I thought I would play for a second what this sounds like. So I'm just going to press play. We'll hear a little bit of what's going on here. I've thrown a compressor on here, so it doesn't sound exactly. I've kind of made it like compress. But we'll see how it sounds. So let's see what we get. Start from scratch. Okay, cool. So hours of fun, tweaking knobs, it's what I like to do. This is the thing, right? So great. Basically, all of these unlabeled knobs, these are things I've broken out that I know that I like to use. This is the power of using REAKTOR, is that I've been able to create a synthesizer that works how my mind's ear wants to hear. So let's dive right in here and take a look at what makes this synthesizer. So this is Core. And a lot of you, I know some people have said that use REAKTOR. How many people use Core? So I can see how many people. Perfect. All right. So for those of you that haven't used Core, REAKTOR is basically split up into two versions. You have primary, and inside primary is a whole nother program called Core. And describing it that way, I find scares a lot of my students. When I say at CalArts, there's another program inside this one, it sounds like the next level. But to be honest, I find core to be as approachable and usable as primary. In fact, a lot of the ideas that you use in primary work directly in core. And some of the things in core make it even simpler in that there's just like one rate. I deal with everything at sample rate. So that means just like every sample, I get a value. So that makes some things very easy. So let's take a step back from core for a minute and see what we're going to do tonight. So what I want to do is talk about the block diagram. This is just an idea of like, how do we make a kick drum? What does it look like? So forget about reactor. How would I make a kick drum conceptually? We're also going to look at the schematic. This is about the most like nerdiest thing I could do, but we're going to look at the resistors and the capacitors and get a feeling for how this thing works. We're also going to look at the details. Great sound is in the details. And then we're just going to build it. So this is my basic kick drum. You can see here, essentially what we're doing is modulating the pitch of an oscillator. We're going to take it from some low frequency where it gets that punch, and we're going to bring it up really high and then sweep down. We're also going to saturate it, and we'll see why we're going to do that in a minute. We're going to put an envelope to control the overall shape of the sound, right? So we don't want our kick drum just droning on forever, so that's how we're going to control that. And then we need a way to add like a click. You know, the difference in sound between a felt beater and a wood beater lends a lot of character to a drum, so we want a way to control that. All right, so this is the fun part. This is the schematic. And this is literally how the 909 worked. This is another thing I love about getting into old rolling gear, is that there is just a wealth of information out there about how it worked. There's schematics, there's service manuals about how you're supposed to fix it if it breaks, and all of that stuff tells us lots of information about how they were thinking when they were making these sounds. So here, the key pieces to see are that we have this down here, see where it says number 10? Does everyone see that at the very bottom? And it says envelope 2. It's kind of at the very bottom, sort of over here on the right side, I guess. And what I want to see there is there's a squiggly line. Anywhere you see a squiggly line on this thing, that's a resistor, all right? And anything where you see like these two lines that look like an equal sign, that's what's called a capacitor. All we need to know is that those two things together create a filter. So if I want to make an envelope, I want my kick drum to have a sharp attack and a decay. I can take these two pieces and put them together and ping them with a pulse. And that pulse will get turned into this beautiful envelope, and this is part of what makes this kick drum. So in understanding when I was going through this, I needed to know how all of this worked. I spent a lot of time looking at this, what's the time constants, how long does it take? And then I took all that information, and in core, I was able to input those numbers and try and emulate the 909. What's also helpful is, okay, looking at the schematic, squiggly lines, equal signs, but what does it really look like? So luckily, people much smarter than myself have gone through and made analysis of all of these parts of the circuit and seen how it works. And I can go in there and look at this and say, hey, interesting things are in this circuit. For example, it is not a sine wave that we're using, but a triangle wave. And we're going to see how that works. And it's really important that we use a triangle wave. Also, the other thing is that this wave, when we use the envelope to shape the kick drum, it always starts from 0. That is so important. And I'm going to demonstrate tonight the difference of not starting from 0 and see what that sounds like. And then they've also given us the time constants. So I don't even need to do the math. I just search over the internet and voila, they give me all sorts of numbers. It's great. And Reactor lets me plug those numbers in and make sound. So enough of this stuff. Let's see how we build a kick drum. Ooh, one more part. Okay. So the details, right. So one thing I do want to point out is if you are interested in getting into this level of how do you build things, looking at these service manuals, there's a wealth of information. And one of the things that's cool is in here, they literally tell us that the kick drum must restart the wave every time you ask for the kick drum. And again, I'll show you tonight why that's important. It'll be very clear. So let's take a look at our kick drum. Before we jump into this more complicated version, I'm actually going to open up a very simple version. Let's open it up in 6. Perfect. Here's our kick drum. Very basic. Let's see what it sounds like. Oh, should turn on reactor first. Oh, that's a kick drum. Okay, cool. So we now have a kick drum, and that sounds like pretty much like a kick drum. It's synthesized. It uses a sine wave. It does what I said in the block diagram in that we're sweeping the frequency of the kick drum down, and we're putting some amplitude envelope. This allows me to control some parameters. I can say things like, let's have the kick drum hang around for a little longer. Right? So that's pretty nice. I can tune it. I can tune it a little higher or a little lower. Right? So there's lots of things I can do here, and maybe this is enough. Maybe this is what we need to synthesize a kick drum. It's in primary, it's very easy to build, but why would we want to build more? Well, I'm going to show you lots of interesting things in building the 909 that take our kick drum to the next sort of step. So the first thing I want to talk about is jumping into the 909. We're no longer using a sine wave, we're using a triangle. And the reason we're using a triangle wave is because a triangle wave has lots of harmonics. A sine wave has one harmonic. It's not even a harmonic, it's just the fundamental. There's like one frequency in there. So that's awesome, as long as your laptop can reproduce that frequency. If your kick drum is lower than the frequency that your laptop speakers can produce, you don't hear it. But a triangle wave contains all of these frequencies inside of it. So that means even if the lowest one is below our speakers, I can still hear part of that. And our brains are amazing in that they can take all of those harmonics that are above and fill in the bass below. So psychoacoustically, if I can hear the harmonics above in my kick drum, I know that that fundamental bass is there. So I'm going to use a triangle. The only problem is a triangle is too buzzy. It doesn't really sound like a kick drum. So I need some way to not be a sine wave, but not also be a triangle. So how do I do this? Well, in the 909, what they decided to do was run your triangle wave through some diodes. And this acts like a clipper. So when I was showing some of these images before, you might have noticed there was a blue triangle wave and then a red, kind of looked like a clipped triangle wave. And essentially we were turning that triangle wave into a sine wave. So I'm actually going to turn down my output here so it's not too loud. And I'm going to demonstrate for you the difference between just the raw triangle wave and a saturated or diode clipped version. So here is our triangle wave, right? And you can hear that there's these tones in it, right? It's not just one tone. And if I take the saturated output of that, you can hear it sounds kind of muted now, right? And I have a way to control that here, so I'm going to split my screen, go to the panel, and I have a way to control this. And let's hear what that sounds like. So we can hear that I'm beginning to add or take away some harmonics here. So this gives me a way to control the timbre of the body of the kick drum. I now have a mechanism for saying my kick drum doesn't need to be just a sine wave. It doesn't need to be this buzzy thing. I can morph between these different timbres. So this was a key piece in designing the 909. And in fact, for anybody that's modded a hardware 909, this is one of the sort of very common modifications is, can I drive my kick drum harder into that diode limiter? So here in Reactor, we've just provided ourselves a way to do that. And one of the things I want to point out very early on, so this is very common with my students, multiplying in Reactor that's how you do your gain. If you want to turn something up, you multiply it, right? So if I want to make something twice as loud, it's 2 times whatever it is. That goes for signals, it goes for MIDI, for anything. If I want to merge signals together, I'm going to use an add. So we've got this multiply here, I'm saturating by increasing the volume and driving it into this saturator here. And that allows me to change the timbre of the body of the kick drum. So I'm going to connect the output back out. And I'm going to zoom out here a little bit. And the next thing we want to do is I want to apply an amplitude envelope, right? So I need some way to control the volume. So in Reactor, there's this notion of envelopes. If anyone's used modular synths or any synths of any kind, you have envelopes. But in Reactor, we have a wide variety of envelopes. So here I have this attack, hold, and release envelope. And why this is important is because what makes kick drums sound really good is when we compress them and you get like this clipped off kind of punchy top, right? You want to run it through a compressor so that the attack portion lasts for a little bit longer. Well, we can just fake that. And in fact, in the 909, this is what they did. They did a 20 millisecond hold before they did the release. So here, I'm emulating that with this hold component in my release envelope. I can go ahead and delete any modulation, delete any noise, and this is just taking that raw signal we were hearing, and I'm just going to apply an envelope to the volume. So let's hear what that sounds like. Make sure I didn't disconnect something I actually needed. When in doubt, restart. Oh, that's better. Okay, cool. So that's where we're going. Okay, all right. So, okay, all I want to do is disable the frequency modulation, disable the noise, and let's see if we can get back to where we were. Okay, great. So now we're getting this amplitude modulation on our amplitude envelope rather, and I broke these out so that we could see them. And there's something very subtle going on in this. So one of the things is you might notice right here, the kick drum jumps up. And remember I mentioned that we need to start from 0. So what is punchier than a kick starting from just like 0 all the way up to full volume? You don't want your kick starting from like somewhere in the middle and then we jump up. We want like the full punch. So you can see here that this envelope restarts from the very beginning. But there's a catch. If we instantly jump down and instantly jump up in digital systems, that causes what's known as a discontinuity or a break in your wave. It causes all sorts of havoc and just sounds very clicky, which we'll hear later on. So what we want to do here, and what Core allowed me to do, was go in and basically zoom in on this part here, and I'll be able to show you that. Ooh. This is going to be very exciting when I zoom in, I swear. Oh, there it is. So here we go. There's a release. We can see that there's like a tiny envelope that I tacked on the end before I had the next kick drum come in. So what this is a way of guaranteeing that my kick drum gets to 0 before I start it again. This prevents any sort of clicking or any other digital artifacts. When people are like, oh, I really like analog, part of that is that it's very easy to instantly restart from wherever you are. But in a digital system, we need to ensure that we take care of these things. So in Core, I made it so that the envelope suddenly changes. And now we have this very quick release, and I can start from 0. Ah, that's a great question. So the question was, how do I recognize when things are going to happen? So basically what I did was I said, the only way I know I want another kick drum and that I need to have the release happen is I've asked for a new one. So I actually delayed the new kick drum by half a millisecond. Turns out that when we're playing music, perceptually, we can't really re-trigger things faster than about 10 milliseconds, and we're not really aware of things that shift less than 5 milliseconds. So half a millisecond is so short, it doesn't really impact how we hear the start of the kick drum. But it's short enough that it removes any of these sorts of clicks. So then the next thing we want to do is add this sort of pitch modulation. This is key. No matter, even if you go to this level of making a kick drum or you go to that one where we have a sine wave, you always need to modulate the pitch of the kick. This is like the quintessential synthesis of your kick drum kind of thing. So again, we have another envelope here. It's all about the envelopes. So we have envelopes, and this one is basically just an attack and decay. So it goes up, it goes down, and we're going to use that to change the pitch of our kick instantly. One last thing I want to point out with the envelopes is we're going to do the same thing with some noise. We're just going to filter the noise here, and use that also to create that. Remember I was talking about the filtered beater head versus the like wood beater head. This noise can be used to get that kind of sort of like soft or hard thwacky attack. So now that we have all three of our envelopes, we're able to modulate this. We've taken care of any clicks. We now have the ability to fully control this kick drum, more than just like this sine wave that has a pitch modulation. With Reactor Core, we were able to get inside here and actually see that we could saturate like the diodes do in the 909. We could get these insanely fast attacks like they were requesting in all of the circuit analysis. And we had the ability to use multiple envelopes to control both our pitch modulation and the noise attack, and we can combine that all into this sort of very authentic 909 kick drum sound. But what is most interesting, and what I want to leave everybody with tonight, is this idea that Reactor allows you to take these ideas. We understand now when they were building this 30 years ago what they were sort of going for, and now 30 years later, we can add new knobs. We can try and build new things. Maybe we don't want the same kick that they did 30 years ago. Maybe now I want to saturate the kick out into the diodes so that it totally clips. And maybe I want this pitch modulation so that it sweeps in and sweeps out. And maybe I want the tuning to be very aggressive, more so than I could ever get on a hardware 909. And now I get some sort of crazy kick drum that sounds like this. Or maybe that's not crazy enough, and we want to do something like this. So, what I would like to leave you with is that while looking at the circuits, looking at how people have done it in the past is a great way to learn about how things can be done. It is just the starting point to then build how things might be done in the future. Thank you very much.